Hi, this is Michael King. Now we're going to look at how to value a bond. This is going to be section 6.2 out of Booth, Cleary, and Rikita. How we're going to value a bond is we're going to use what I call the magic formula. The magic formula is a formula that will allow you to value any asset. As you can see, the value of any asset is going to be the present value of all the cash flows that the asset is expected to generate, discounted to today at some discount rate. And that discount rate is going to reflect the risks inherent in those cash flows. So when we apply this magic formula to valuing a bond, we can see that a bond is actually a string of cash flows. It is the coupons as well as the face value that's repaid at maturity. And to find the price of a bond, we're simply going to discount those cash flows to find their present value, where the discount rate is going to be a yield to maturity. So in order to value a bond, we need to know three things. We need to know what are the coupons, when do we receive them, and what is the discount rate. So valuing a bond, we're going to see is actually a combination of the annuity formula and the present value, future value formula. You can think of the coupons on the bond as an annuity because they typically are fixed and payable on regular periods. And then we get the face value back at maturity, so we need to find the present value. So before using this formula, you need to know something about the conventions for compounding with different bonds. Compounding is how many times per year the coupon is paid. European and Japanese bonds pay interest annually. Whatever the interest rate is on the bond, you just multiply it by the face value to figure out the annual coupon. North American bonds, however, pay interest semi-annually. You have to take the coupon on the bond, divide it by 2 when multiplying it by the face value to figure out what the coupon is. With semi-annual compounding, which is true for Canada and the US, you need to adjust three things: the coupon, the number of periods, and the periodic rate. Let's take a look at an example. Calculate the price of a 2-year bond with a face value of $1,000, paying a coupon of 4% semi-annually when the yield to maturity is 5%. Face value is going to be $1,000. This is at the future value. The coupon, however, is going to be 4% divided by 2 for semi-annual compounding, multiplied by $1,000 face value, or $20 every 6 months. The number of periods is going to be 2 years times 2 periods per year, or 1 every 6 months, or 4 periods. And the periodic rate is going to be the yield to maturity of 5%, divided by 2 because of semi-annual compounding. And so the periodic rate, or the rate for every 6 months, is going to be 2.5%. Here you can see the formula, which combines an annuity plus the present value of the face value. So the coupon is going to be $20. The discount rate is going to be 2.5%. The number of periods is going to be 4. And as you can see, the price of the bond is going to be $981.19 for a bond that has a face value of $1,000. Okay, let's look at another example. Here we have a European bond with annual compounding. Let's say the bond has a face value of 100 euros, a coupon of 5.375%, payable annually, and it matures in 6 years. What is the price when the discount rate or yield to maturity is 3.8%? You may want to draw out a timeline to show the cash flows. As you can see, because it's an annual bond, there are going to be 6 cash flows, or 1 per year. The coupons are going to be 5.375% times 100 euros, or 5 euros, 0.375 cents. The face value is going to be repaid in the final period at the end of 6 years of 100 euros. And our discount rate is going to be 3.8%. We can use that discount rate to calculate our present value interest factor using our knowledge that it is 1 over 1 plus k to the n. And so, for example, €1 received in 6 years would be 0.7995 euros today. What's the intuition? Well, the intuition is that if you invested 0.7995 euros today, compounded annually at 3.8%, it would grow to be exactly €1 at the end of 6 years. To find the present value, you simply multiply the cash flows times the discount factor. You can see that the final cash flow of 100 plus the coupon payment of 5.375, so 105.375 euros. In today's dollars or present value terms is going to be 84 euros and 25 cents. As a holder of the bond, you receive all 6 cash flows, so you simply add them up to find out what the price would be, and the price is going to be 108 euros and 31 cents. Let's look at a North American bond with semi-annual compounding. Let's say you have a 2-year bond with a $1,000 face value, a 4% coupon payable semi-annually. What would be the price when the yield is 5%? Okay, so how many periods do we have? We have 4 periods because it's a 2-year bond with semi-annual coupons. The coupons, they're going to be 4% divided by 2, multiplied by $1,000, or $20 every 6 months. The face value does not change, it is $1,000. The discount rate, well, the discount rate is going to be 5% divided by 2, or 2.5% for every 6-month period. Using that, we can calculate the present value interest factor using 1 over 1 plus k to the n. You can see here that the discount factors start close to 1 and then decline as you go further out. The intuition is that $1 received at the end of 4 periods would be worth 90.6 cents today. Multiplying the cash flows times those present value interest factors, the value of the bond is going to be $981.19. Let's look at another example. Let's say you have a bond that has a 10% coupon payable semi-annually and 10 years to maturity. What is the price when the yield to maturity is 8%? Future value is going to be $1,000. The coupon is going to be 10% divided by 2, multiplied times 1,000 to get $50 every 6 months. Number of periods is going to be 10 years times 2, or 20 periods. And the discount rate is going to be the yield to maturity of 8% divided by 2, or 4% per period. Plugging it into this formula, we can see that the price of the bond is going to be $1,135.90. The bond is going to be trading at a premium to its par value. If we were to do this in Excel, we would set it up this way, where we have a table. In each row, we have a different period, and we can put the different cash flows as well as the discount rates in the columns. You can see that we have 20 periods, where in each period we receive a coupon of $50. In the final 20th period, we receive our $1,000. That leads to cash flows need to be discounted. The yield to maturity actually has to be divided by 2 to get our periodic interest rate of 4%. We use that to calculate our discount factors. We multiply our discount factors times the cash flows. We sum up those cash flows to see that the price is $1,135.90 in the bottom right corner of our table. Last one. A bond has a 10% coupon and 10 years to maturity. What is its price when the yield to maturity is 10%? Okay, now the discount rate has 10% divided by 2, or 5% per period. Notice that the other inputs have not changed. The price will turn out to be 1,000. Why is that? Why is the price equal to the face value? Well, the intuition is that you're going to be growing your money at a rate of 5% every 6 months, and you're going to be discounting it or finding the present value using a discount rate of 5% every 6 months. The bond is trading at its fair value of $1,000, which is the face value. That's it. We'll get lots of opportunities to try price in our next class.